Hey, Bengals. We're going to take some notes today about speed, velocity, and acceleration. So go ahead and pause the video and make sure you have your science journal and some colorful pens and pencils to make your notes pop. All right, the essential questions. What should you be able to answer by the end of this video? Number one, what is the difference between speed, velocity, and acceleration? Number two, what unit of measure is used to describe each of these? And number three, what is the formula for calculating speed? Let's get started. Remember, motion is a change in position relative to another object, right? So that was part of your vocabulary that you worked with earlier in the week. Okay, I would like you to set up your notebook page like this. So you're going to have three sections, one for speed, one for velocity, and one for acceleration. Leave room in each section for you to give a definition, write the formula, and then put some examples of the units of measure. So again, you may want to pause the video and set up your page to look like this. All right, we're going to start with speed. Okay, the definition for speed. Speed is the change in distance over a specific amount of time, like how fast an object is moving. So go ahead and write that definition down on your paper. The change in distance over a specific amount of time. So if your speed is fast, you'll have a large change in distance. You'll move really far in a short amount of time. But if you're slow, you may have a short distance covered in a long amount of time. Okay, the formula for calculating speed, back from sixth grade, you learned this in sixth grade, speed equals distance divided by time. Okay, and I would like all of you, no matter how confident you are in your skills, I would like you to write this triangle, the speed, distance, time triangle. And notice that distance is on the top of the triangle and speed and time are on the bottom sections. So if you are given a word problem that tells you the speed and the time, and you have to calculate the distance, you know you're going to have to multiply the speed times the time to get the distance. If you're given a distance and you're given the speed or the time, you know you'll have to divide to find the other. So this triangle is a really helpful way for you to solve problems related to speed, distance, and time. Okay, so write that in the formula section of your notes. And then finally, for the units, the unit of measure, right? We never have a naked number, no naked numbers. So if you get an answer and it says 8, we need to put a unit of measure with it. So examples that a unit of measure for speed could be meters per second, kilometers per hour, meters per minute. Basically, you're going to have both a distance and a time in your answer, like meters is a distance and seconds is a time, meters per second, or kilometers is a distance and hours is a time, kilometers per hour. Okay? Next, let's move on to velocity. So now we're going to look at the velocity section of your notes. So your definition of velocity, it's a term that refers to both speed and direction. So you don't have to write the whole thing, but speed with direction. So velocity and speed are essentially the same thing, except velocity is going to tell you which way you're going. Okay. So here it says, you might say the car is traveling at 50 kilometers per hour north. So 50 kilometers per hour is the speed, north is the direction. So together that's the velocity. Okay. Instead of saying north, south, east, west, up, down, left, right, arrows or vectors can also be used to show an object's motion. Okay, the speed then, the formula then is the same as the formula for speed. You're just going to put the direction at the end of it. So again, you may want to list this triangle, okay, and then plus direction. All right, so look at the box there. It says which of these shows speed and which shows velocity. Okay, so I'm going to circle the ones that show velocity, right? 67 meters per second south, because it gives a direction, it's a velocity. 90 kilometers per second up. okay, because it gives that direction, even though it's just an arrow or a vector, that's the velocity. The other two examples are examples of speed. They don't tell us the direction. Okay, and the unit of measure, I've given you some examples. It'll look just like the units of measure for speed, except it will include some sort of direction or arrow vector with it. And finally, we have acceleration. Okay, acceleration is when a force is applied to a moving object. The object can speed up, slow down, come to a stop, or change direction. Okay, so please, when you write your definition, put that. A force applies to an object that will cause it to speed up, slow down, come to a stop, or change direction. All of these are examples of acceleration. Normally, when we talk about acceleration, we think about just speeding up, but technically, any change at all is going to be an acceleration. Okay, so you might want to put that word real big next to acceleration, a change. Okay, now the formula you can put on your paper is speed, distance divided by time again, because it's first you would find the speed and then you would divide that by the time you were finding the speed to see how the speed changed, because acceleration is a change. But you're never going to be asked to calculate that in our class, so don't panic, okay? If you would like to add some examples of acceleration on the back of your paper, that's a great idea. There's a few here listed for you: stepping on the brakes, pedaling your bicycle faster, dropping your lunch tray, the dog chasing its tail over here, all of those things. Okay, for the unit of measure, please take note. It's going to be meters per second squared. Look at the little 2. And that's because we're doing meters per second, the distance or the speed, divided by the time. So meters per second, which we're going to call meters per second squared. So that little 2 is going to be your key that you're looking at an acceleration. Okay. All right. Those are your notes. You should have all 3 sections filled in at this point, and go back and look at your essential questions and make sure you're able to answer those. Good job, Bingles.